Hey guys, uh, just very excited to be bringing you your first online notes today. So just as like a reminder, these documents. Hi, by the way. These documents are posted on both Google Classroom and on School Loop. So if you're like, wait, there's a notes handout, and you're looking for it, you guys can find that on School Loop or on Google Classroom if you want to print it out and like fill it in along with me, or if you just want to write out the notes, like handwrite them, totally fine. Whatever you guys feel comfortable with, then definitely do that. But we are going to get kind of started with notes. So we are still in chapter 8, but we split up. See, my pens are still here. We split up chapter 8 into 2 sections. So we are going to be, this is actually like circling back to 8 too. But we split up the chapter 8 into one was multiplying, which you guys already did, and you tested on it on Friday. And then this one is going to be factoring. Factoring is essentially just like the opposite of multiplying and like what we were doing. So that's where we're going to get started here. What is factoring? So factoring is undistributing. So undistributing. I don't know if that's a technical term, but that's the term that we're going to use. Factoring is basically taking something that's common from all of the terms and pulling it out and leaving what's left inside parentheses. So what you guys are used to actually seeing is the factored form. So the factored form is something like this, like 5x times 3x minus 8. So the factored form is basically the same as like me saying, it's the form before we multiply everything together. And so what we're going to be doing instead of multiplying, we're going to have the distributed form, and we're going to actually be going to the factored form. So distributed is just if I were to distribute this 5x to both terms. So 5x times 3x, 5 times 3 is 15, and then x times x is x squared. And then 5x times negative 8, well, 5 times negative 8 is negative 40, and then the x doesn't combine with anything else, so we just leave it as x. So like I said, what we're going to be doing in this unit is we're going to be going from the distributed form to the factored form. Now, some polynomials can't be factored at all. They don't have a common term that can be divided out. And so what we call those polynomials that can't be factored are called prime. Prime is just like saying the same as like not factorable. So the greatest common factor, that's something that like you've talked about, like what's the greatest common factor? Remember factor, like the factor of 18, the factors of 18 are the numbers that divide evenly into 18. So like the factors of 18 would be 1, 2, 3, 6, 9, and 18. And so when we're thinking about the greatest common factor, it's the greatest common factor is the largest whole number that divides evenly into 2 or more terms, because we're going to be looking at multiple terms to figure out what's the greatest common factor. So it's basically just saying what's the greatest like number or variable. We're going to talk a lot about variables too. That divides everything, like divides evenly into all of those terms. So, okay. So steps for factoring a GCF. And this is going to be something that's super important. We're going to be focusing on factoring a GCF a lot. But the first thing that we want to do is we want to look at the coefficients first for a GCF. Now remember the coefficients. Let's make sure I spell it right. Coefficients is just the same as like the numbers. So it's just a fancy like math way of saying we're going to look at the numbers first. Now, after we've looked at the coefficients or the numbers to see if there's like a GCF or greatest common factor in those, notice I write most of the times GCF instead of greatest common factor, just because it's easier. Okay, so after you've looked at the coefficients, so the numbers in each of like the terms, we're going to then look at the variables. A variable must be common to all terms to be a GCF. So every single term has to have that variable for it to be a GCF. So if a variable is common to all terms, you take the one with the smallest exponent. Then what you do, so once this is basically you figuring out like what is the GCF. So we can kind of write that in actually. So this first step or these first two steps is you determining, I'm not going to be able to fit it, determining what the GCF is. And then, so once you figured out what the GCF is, you're going to divide all terms by the GCF and leave the remainder in parentheses. And you can, the nice thing with being able to like factor is you can always check it. If you kind of circle to like back up here, what we're going to be doing is going from the distributed form to the factored form. And if I wanted to check to make sure that I did it right, all I have to do is just multiply it out, or we check, or you can always check your work by distributing. Or, you know, another way of like thinking about it is just like multiply it out. So that's kind of the process. Now I kind of want to circle to back up here and talk about like how I went from this to this, because we first initially went to the factored form to the distributed form. So if you look, if I'm looking here and it says first look at the coefficients, I look at 15 and 40. And I think, what's the biggest number that divides evenly into 15 and 40? So I know that sometimes that's hard to think about and think like, okay, what are the numbers? But I usually, like, if I'm stuck and I can't think about it, then I will actually write out the factors. I write out the factors of 15, 1, 3, 5, 15, and then I write out the factors of 40. That's probably a lot more. So I'd write out 1, 2, 4, I'm sure I'm going to miss some, 5, 8, 10, 20, 40. I don't think I missed any. Props to me. But then I'm looking to see what's the biggest number that they both have in common. The biggest number that they both had in common was 5, which is where this 5 comes from. And then it says, now look at the variables. A variable must be common to all terms to be a GCF. So if I look here at x squared and x, what it means by common is there an x in both of these? And there is. There's an x squared and there's an x. And so if the variable is common to all terms, you take the one with the smallest exponent. The reason we do that, we take the smallest exponent, is because like this one has 2 x's and this has 1. Well, I can take 2 x's from this one, that's fine, but I can't take 2 x's from this one. So you always just take the smaller like amount. So you can take 1 from this one, you can take 1 from this one. And so that's how we got that like GCF. This is technically the GCF. And so that's how we get the GCF. That's how we get the number that's on the outside of the parentheses. And so then we divide. So we think about, okay, 15x squared divided by 5x. Well, 15 divided by 5 is 3. And x squared divided by x is x. And then I move to the next one. Okay, well, negative 40 divided by 5 is negative 8, and x divided by x is 1, so it goes away. And so that's how we get that. Again, we can check it by distributing, which is how I got here in the first place. So let's kind of look at some examples. I know that this is like typically my time where I would do, and like I do one and then you guys try it and then I come around and check it. So what I'm going to still do is really encourage you, like I'll do one with you, and then I would encourage you guys to try one on your own. And then I'll still explain it, but then you can check to see if you did it correctly. So still like try these out on your own and, you know, treat it as if I'm there. I just can't physically be checking your work. So, you got to just take ownership and check it yourself. So, okay, so this first one, let's kind of go through the steps. So it says factor each polynomial, check your work by distributing. If a polynomial cannot be factored, rewrite prime, just like it said up there. Polynomials that can't be factored are called prime. So our first step is to look at the coefficients. We look at 12 and 20 and think about, okay, what's the biggest number that can divide evenly into both 12 and 20? So what I was saying up here with like listing them out, if you want to, which you don't have to, a lot of you guys can do this in your head, but you can list out the factors of, okay, what are the factors of 12? So the factors of 12 would be 1, 2, 3, 4, 6, and 12. I should have written smaller, sorry. And then, okay, what are the factors of 20? Okay, so we know 1, which doesn't really help us that much, but okay, 2. Oh, that's 1, but there might be one that's bigger. 4. Okay, 5, 10, and 20. And so I think, and I look, okay, well, greatest, we're looking for the biggest thing that they have in common. So the biggest number that they have in common here is that 4. So when I look at the coefficients, I'm going to my GCF right now to start with is 4. Now, so I figured out my coefficients. And again, you don't have to write this out. Like this is only to benefit you, to help you to kind of see that. If you know, like you can do this in your head, great. Then you can do that in your head. So then I look at my variables. Remember, a variable must be common to all terms. So this has an x, but this doesn't. So we actually can't factor out a variable. I can't factor out an x from this one, but not this one. It has to be something I can divide from both of these. So actually, our GCF is just 4. So what we're going to do is we are going to then, you're always going to write your GCF on the outside. And then what's left is basically what happens when you divide the GCF by each term. So 12x divided by 4. And so I think, okay, well, what's 12 divided by 4? That's 3. And then the x doesn't change, so we just bring it back down. And then I do the same thing. 20 divided by 4. Well, 20 divided by 4 is positive 5. And that's your final answer. Now, I always go back and kind of double check, okay, 3x and 5, is there anything that I could technically divide out of those? There isn't. And then I mentally, I won't show my work to do this, but I mentally do it. I think, okay, 4 times 3x is 12x and 4 times 5 is 20. So we're good. And that's our first answer. Yay. Okay. That was exciting. Let's look at 2. So with 2, what I really encourage you guys to do is pause the video right now and try 2 on your own. And then once you've tried it on your own, then come back here and check your work against mine to see if you did it right. So pause right now, do it on your own, and then come back and check. If you haven't paused it already, you should have at least paused it to try it. Come on, you got this. Okay, so at this point, you're unpausing me because you've tried your best to do this on your own. You've walked through the steps, and now you're just coming back to check. So if you went through this process, we first looked at the coefficients, 4, 8, and 12. Now, if you need to, like, every time write it down, you can. So, like, we could write it over here. The factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, 4, and 8. And then the factors of 12 are 1, 2, 3, 4, 6, and 12. And so I look and I figure out, okay, well, what is the biggest number that divides evenly into 4, 8, and 12? And it's actually 4. So I start there. And then I look at my variables. So my variables, x cubed, great, this has an x. X squared, this has an x, we're on to a good start. And then 12x, that has an x too. So they all have an x. Remember, a variable must be common to all terms. So every single term has an x here. And then you're going to take the one with the smallest exponent. So I look, there's 3 x's, there's 2 x's, there's 1 x. So the smallest one there is x to the first power, which we don't need to write that 1. So remember, your GCF is always the number that's outside the parentheses. And the parentheses are what's left once you've divided. So if you need to write this out every time, like we're dividing by 4x, great. If you don't need to write that out and you can do that, like, in your head, that's great too. So do what you need to do to feel confident with going through this. So 4 divided by 4 is 1, which we don't need to, if it was just that, we'd write it, but we're going to not write it right now. And then x cubed divided by x is x squared. You can write 1x squared, but we're just going to write x squared. Now, negative 8 divided by 4, we know is negative 2, and x squared divided by x is x to the first. Remember, we have 2 x's, we take away 1, we're left with 1. We have 3 x's, we take away 1, we have 2. And then 12 divided by 4 is 3, and x divided by x is 1. So 3 times 1 is just 3. And then I end my parentheses. Remember, this is like a new fact, but if you notice, like this one has 3 terms, 1, 2, 3. And what's inside the parentheses should also have 3 terms, 1, 2, 3. So this one had 1, 2 terms, and what's inside the parentheses, there are 1, 2 terms. So if you had like 5 terms, you should have 5 terms inside your parentheses. Okay, so that is your final answer. So exciting, that factoring. It's actually a unit that I do really like, and I'm sad that I can't teach it to you guys in person, but hopefully this is working and hopefully you're understanding it. And if you're not, then please come into the Hangout, the Google Hangout or the Google Meet. I'll send that out to you guys, or I've already sent it out to you guys, so you can check that out. Okay, so let's look at 3. Again, like if you're feeling super confident with that, you're like, I got that right, I'm going to try 3 on my own, then pause the video right here and try 3 on your own, and then come back and check to make sure you did your work. I really encourage you guys to do that with a lot of these to make sure that you can do it on your own, because at the end of the day, that's what we care about. So we have 5x squared minus 15x. Now, again, you guys can write it out, or we can just kind of mentally think about it. What's the biggest number that goes into 5 and 15? And kind of a trick that I always do is I look at the smallest number, and I think, okay, well, can 5 go into 15? And it can. And so that's actually my GCF. Okay, and then I look at my variables, x squared and x. This has an x squared, great, and this has an x, so we can actually take out an x, and I look at my smallest exponent. So this has 2, this has 1, so x. And so that's the number that I'm going to always write on the outside of my parentheses. And then what's left, if you need to write that and divide, then divide. So 5 divided by 5 is 1. If you want to write the 1 there, that's totally fine. You don't need to. And then x squared divided by x is x to the first power. And then negative 15 divided by 5 is negative 3, and x divided by x is 1. So negative 3 times 1 is just negative 3. Remember, you can always check it back. Like 5x times x is 5x squared, and 5x times negative 3 is negative 15x. So you can always check your work, which is super nice. We always like that ability to check our work. So, okay. We're going to move on to 4. Again, if you're feeling confident, feeling good, pause it here. Try it on your own, but I'm going to keep going. So I won't say it again, but with all of these, like pause it before, try it on your own, see how you do. Like especially, these are kind of building up, and so try to see how much you can do before you're checking your work against mine. Okay, so 5x squared y plus 20xy squared. So we have more variables here. It's okay. It doesn't really change much. So we always start again by looking at the number. Remember my trick back here? I said look at like the smallest of the two. And I look at the smallest of the two as 5. And I think, okay, I know it goes evenly into 5. But does it go evenly into 20? And it does. 5 goes evenly into 20. So we're going to start there. Okay, so then I look at my variables, x2 and x. Okay, they both have an x, so that's great. We take the smaller of those. This is x squared, and this is x to the first, right? Because it doesn't have a variable. We always assume, it doesn't have an exponent, so we assume it's 1. So we can take out x. And then, but wait, there's another variable. So we look to see, okay, y and y squared, they both have a y. That's great. So we can take a y out. y1, y2, the smallest of the two is y1. So that's my GCF. So that's the number that goes on the outside of the parentheses, or that's the term. And then we just divide through 5xy, and then 5xy, and do the math there. Now, I know this kind of can look daunting here because, there's a lot of variables. I just really do it part by part. 5 divided by 5 is 1. X squared divided by x is x. And y divided by y is 1. Well, 1 times x times 1 is still just x. Okay, and then 20 divided by 5 is 4. X divided by x is 1, so we don't need to put it there. And then y2 divided by y1 means that there's 1 left. And again, you can distribute that. 5xy times x is just 5x squared y, which is just up here. And then 5 times 4 is 20. X comes down. And then y times y is y squared. Okay, so then we'd keep going. 12x to the 5th plus 6x. So I am, first looking at my numbers, 12 and 6. Thinking about what number goes evenly into both of those. I still am looking what's the smallest number here? 6. Does 6 go evenly into 6 and 12? And it does. And then I look at my variables. Does this have an x? Yep. Does this have an x? Yes. So the smaller of the two, 5 and 1, I can take out 1. So that's always the number that goes on the outside of the parentheses. And then what's inside the parentheses is what's left once you've divided. So I want you guys to be careful that you write this one down correctly. So make sure you do. So 12 divided by 6 is 2. And x to the 5th divided by x is x to the 4th. Now what's tricky is this part. So 6x divided by 6x. 6 divided by 6 is 1, and x divided by x is 1. Well, anytime it's like divided by itself, we know it always gets 1. And remember what I said, like this is kind of like one of the most common mistakes is oftentimes people won't write this. But remember what I said up here. I said no matter how many terms you have, we had 3 terms here, you should have 3 terms in your parentheses. You have 2 terms here, you have 2 terms in your parentheses. 2 terms, 2 terms. So here I have 1, 2 terms, so I have 2 terms in my parentheses. Okay. So let's look at 6. And you guys, if you throughout this like have a question and you're unsure about something, like star it, circle it, like, highlight it in wherever you're struggling, and then bring it into office hours, and you can like remind yourself kind of where you're struggling and what went wrong and where I can help you, because then you have that face-to-face chance where you can ask me those questions. Okay, so let's look at 6. So we look at our numbers, -6, 3, and -9. Now, with this one, it's kind of like there's 2 ways of thinking about this, but typically, let's start with just the numbers. So 6, 3, and 9. So like I said, my trick is I look to see the smallest number. The smallest number is 3. And I think, does 3 divide evenly into 6 and 9 also? And it does. And so this is kind of like a mixed case, but I don't like to have a negative in front here. So I actually, like if this number is negative, I'll factor out, instead of a +3, I'll factor out a -3. If you factor out a +3, that's just going to change the inside of like what our parentheses are going to have. I just prefer, I think it looks like neater. I don't know, nicer. I think it's like more mathematically correct if you factor out whatever sign is of the first one. So I look at my variables. This has an X, great. This has an X, great. Oh, but this one doesn't. So we can't just factor it out from 2 of the 3. Remember, a variable must be common to all terms to be a GCF. So -3 is my only GCF there. And then I just divide. So be careful because the sign is important. So -6 divided by -3 is a +2. The x's aren't going to change because we didn't divide anything by the x's, so x squared. And then 3 divided by -3 is -1. And then x is just going to stay there. You can put -1x, that's fine. And then -9 divided by -3 is +3. Again, you can always check your work. -3 times 2x squared, -6x squared. -3 times -x, positive, because that negative and a negative, +3x. And -3 times 3 is -9. Okay, 2 more. So, almost done. It looks like a doozy. I promise you, it's not that bad if you just look at it kind of step by step. So let's look first at the coefficients. Let's look at the numbers. 6, 36, and 18. Again, do my little trick. Think about, does 6 go evenly into 36 and 18? And it does. And then I look at my coefficients. So I look at them just piece by piece. X to the 5th has an X, has an X, has an X. So I look to see, of those, what's the smallest exponent? 5? No. 4? No. 2. So x2. And then next step, I just look at the next variable. y2 has a y, has a y, has a y. And so again, I look at the smallest amount. 2, 3, or 2. Well, the smallest one is y2. Okay, so that's the number that comes down. So 6x squared, y squared. And then I know like the dividing seems a lot, but like I did up above, just take it step by step. So 6x squared, y squared. 6x squared, y squared. Okay, so 6 divided by 6 is 1. You guys can write the 1. You don't have to write the 1. The only time is like you have to write the 1 is when the entire thing divides and you're left with just 1. So that's when you have to write the 1. Here, x5 divided by x2, we still have an x3. Because if you take 2 from 5, you're left with 3. Well, and y2 divided by y2, that divides by itself, so it's 1. So the only thing that's left is that x cubed. And then 36 divided by 6 is 6. X4 divided by x2, so take 2 away from 4 is 2. And then y3 over y2, so take 2 away from 3, and you have, y. I don't know why I ended my parentheses. I got a little ahead of myself, so let me get my white out. Don't worry, guys. I still have it. And then we move to our last term. So negative 18 divided by 6 is negative 3. X2 divided by x2 is 1. And y2 divided by y2 is 1. So we're just there with the 3. Now I can finish my parentheses. And, because this one was kind of a weirder one, I double check. I look, okay, there's 1, 2, 3 terms. And I have 1, 2, 3 terms. And I go back and kind of circle back to make sure I distribute and get the same thing. 6, okay, x squared times x3, x5, and then y2. That makes sense. 6 times negative 6 is negative 36. x2 times x2 is x to the 4th. And y2 times y1 is y cubed. And then 6 times negative 3 is negative 18. x2, yep, y2, yep. So we're good. Okay, last one, and then we're done with this section. So 12xy squared plus 9xy plus 27y. So again, I would start this process by looking at the smallest number, 9. And I think, okay, well, we know that 27 divided by 9 gets me a whole number, but 12 divided by 9 doesn't. So I have to think about what's my GCF there. It's something that's going to be smaller than 9. Now, again, like if you guys want to, let me just move this up a little so I can write it below. If you guys want to write it out and, write out what are the factors of 12, what are the factors of 9, and what are the factors of 27, then do it. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 9 are 1, 3, and 9. And the factors of 27 are 1, 3, 9, and 27. So I look and I think, okay, well, what's the biggest number there? We want it to be 9, but this one doesn't have a 9. And so the GCF there is actually 3. And then I look at my variables. So x, that one doesn't have an x. So I can't take out an x there. Y, we're good. So we look to see the smallest exponent. So the smallest exponent, 1, 1, or 2, the smallest exponent is y1. Okay, so then I put 3y on the outside. Probably should have written it a little bit lower. And I'm going to divide everything through by 3y. So 12 divided by 3 is 4. X, we're not dividing anything by x, so the x's don't change. And then y2 divided by y is y to the 1 power. Plus 9 divided by 3 is 3. X stays the same. Y divided by y is 1, so it goes away. And last but not least, 27 divided by 3 is 9, and y divided by y is 1, so it goes away. And that's it. That was my final answer. And that is 8-2, factoring a GCF. So, that's your notes for today. So you guys, if you're, trying to keep some sense of normalcy, put that in your spiral, put it in your notes section. We're going to be coming back to this section a lot. So, use that, and hopefully you feel confident with that. And then we're going to kind of add on to that on the next lesson. So remember, if you guys have any questions about this or about your homework, again, check Google Classroom or check School Loop for your homework. But if you guys have any questions, that's what office hours are going to be for. I'll be there. You guys can Google chat with me, Google Hangout, whatever it is. And you can ask me like those one-on-one questions. You can just be in there and pop in and listen to like other people's questions. So that's kind of what that is meant for. So if you guys have any questions about anything on the notes, please, please, please bring them to office hours and we can kind of talk them through there. So I hope you guys have a great day, and I miss seeing your faces, and I hope everything is well. And there you go. Lesson 1 is done.